Hey, today we're going to look at a clever technique for using the derivative to approximate the values of functions. It's known as linearization or sometimes linear approximation. And we'll start right in with an example. We'll try to approximate the square root of 1.1. And here's the basic idea. Here's a graph of the function y equals the square root of x. And 1.1 is very close to 1. And if we look at the line tangent to the curve y equals the square root of x at the point where x equals 1, then you can see that at least near that point, the values on the tangent line are extremely close to the values on the curve square root of x, making them excellent approximations of the values of the square root of x for x values near 1. And so our first step in answering this question, what is the square root of 1.1, will be coming up with the equation of the line tangent to the curve y equals the square root of x at x equals 1. And we know how to find the line tangent to any curve. We use the derivative to find the slope of the tangent line. And it's easy to compute the derivative once we've rewritten square root of x as x to the 1/2. And then evaluating the derivative at 1, we get 1/2, 1 to the negative 1/2. Well, 1 to the negative 1/2 is 1 over the square root of 1, and the square root of 1 is just 1. And so we find that the derivative evaluated at 1 is equal to 1/2. And that tells us that the equation of the tangent line is y equals 1/2 x plus b for some value b. And we're looking for the tangent line at x equals 1. And when x equals 1, it's easy to see that y is also equal to 1. And that lets us solve for b, and we get that b is equal to 1/2. And so the tangent line, the equation of the tangent line to this curve y equals the square root of x at x equals 1 is y equals 1/2 x plus 1/2. And looking back at the picture for just a moment, just to understand what we're about to do, here we have the tangent line, y equals 1/2 x plus 1/2, which is tangent to the curve y equals the square root of x at x equals 1. And you can see that if you put in any x value near x equals 1, well, then the value that you get if you plug it into this curve is very, very close to the value that you get if you plug it into that curve. And that's what's going to let us approximate the square root of 1.1. And in particular, plugging x equals 1.1 into the equation for the tangent line, we get y equals 1/2 times 1.1 plus 1/2. Or after you finish the arithmetic, you get that y is equal to 1.05. What does that tell us? That gives us our approximation for the square root of 1.1. We know the square root of 1.1 approximately 1.05. I just want to look at the picture one last time. 1.1, some point slightly to the right of 1, and you can see that the tangent line is actually slightly above the curve, the square root of x, so you expect the approximation that we came up with to be ever so slightly too large. And if you plug it into a calculator, you'll find that the square root of 1.1 is approximately 1.0488088, etc. It's a non-repeating decimal that goes on forever. Still not so bad, an approximation of 1.05. I mean, before we did this work, if I asked you what the square root of 1.1 is, probably the best you could have come up with is, oh, a little bit bigger than 1. And so here we've got something significantly better than that. And that's the whole idea. You try this one, see if you can come up with an approximation for the natural log of 0.9. Do it the same way. Find the line tangent to the function f of x equals the natural log of x at some convenient point very close to 0.9, like for example x equals 1, which is especially convenient because you know the natural log of 1. Natural log of 1 is the number you would raise e to in order to get 1, and e to the 0 is 1. And so the natural log of 1 is 0. So take a few moments, come up with the equation of the tangent line, and then see if you can approximate the natural log of 0.9. Pause the video, and when you're ready, start it back up. We start with the function f of x is the natural log of x. We take its derivative is 1 over x, and then we evaluate that at the point 1. F prime of 1 is equal to 1. That tells us that the equation of the tangent line to this curve at x equals 1 is y equals 1x plus b, or just x plus b for some value of b. And we can solve for b by plugging in the values of x and y. We know that x is equal to 1, and so when x is 1, y is 0. And plugging those values in, we get that b is negative 1. And that tells us the equation of the tangent line at x equals 1. That tangent line is y equals x minus 1. And if you plug x equals 0.9 into the equation of the tangent line, you get 0.9 minus 1, which is negative 0.1. And from that, we can conclude that the natural log of 0.9 is approximately equal to negative 0.1. And if you plugged it into a calculator, you would see that we were pretty darn close. Natural log of 0.9 approximately equal to negative 0.10536, etc., and on forever. Okay, and that's the whole story about linearization or linear approximation. Pretty cool technique, very simple, just uses the equation of the tangent line. It's a little bit limited in that you'll never be able to say, I want to know the square root of 1.1 to the 10th decimal place, and use linearization to figure that out. If you want to do that, there are some techniques. They're significantly more complicated. Look up Newton's method if you're interested. We will not be studying that this semester, but we could. We're just not going to take the time to do it. And you could certainly understand it at this point. It'll just take a little bit of work. For now, we'll just content ourselves with linearization. There's a homework on it. Take a stab at that. It's just a couple of problems. Have a lot of fun with it. Looking forward to seeing you in class.